All right, so let's talk about MongoDB. All right, so MongoDB. So MongoDB is one of several non-SQL databases. There's plenty more, like Cassandra, CouchDB, Redis, DynamoDB, and a whole bunch of them. Although we've been spending most of our time talking about relational databases, it's not the only way of structuring data and representing it at a lower level. They played a huge role early on in when folks started to build actual applications, and it was a good way of thinking about how to structure data. You have these disjoint pieces of information that somehow they can relate to one another by pointing foreign keys to primary keys, and it was basically an implementation of set theory, right? Of how is it that you had these disjoint sets, right, that might have references to each other, and then you can do set operations on them to find and filter out the data set that might met a particular criteria. Certainly, there were a lot of other alternatives on how we could have stored data, and there's certainly other technologies that are specific to other types of problems that, for instance, real-time databases or graph databases that structure their information in graphs that reference each other in data points, or that are specifically targeted for types of problems that are real-time, right, where they don't have a static set of information, but information is always streaming in, right? That there's an infinite set of streams of data that just keeps coming in, right, and somehow needs to be stored in real time, and needs to be able to be queried in real time, right? And typically there's a window of a time frame where a particular query might have any particular meaning or particular context. So there's certainly a much larger family of problems that databases try to solve, right? And relational database is just one subset of those types of problems. Lately, with the advent of the internet and web technologies in particular, and the explosion of the amounts of data that we've been gathering since the beginning of the century, much bigger problems have arisen. We're gathering more information than we could ever possibly process, right? We have this huge problem that data is just growing exponentially, and there's no way that anybody could possibly make any sense out of it. So we have to start looking at algorithms that can just churn through all these huge amounts of data and make some and group it for us and aggregate it for us and relate it amongst different pieces of information. A lot of that information is very unstructured, so it doesn't fit nicely into the fixed schema that we might come up with in a relational database, right? The relationships, we don't even know what the relationships are, right? So we might have trying to throw some really smart algorithms, artificial intelligence algorithms that can churn through this data and identify relationships that we would have not known that there were any relationships, right? With that information that is completely unstructured, that have properties that come and go, right? So certainly some of these bigger problems that have arisen, relational databases don't fit nicely in to solve some of these. Okay, other databases like MongoDB have arisen to the challenge, and how is it that we could deal with this types of data. Data that is unstructured is very, very big. It usually is spread over a large geographical area, right? That's data that might be relevant, perhaps the same database, but there might be pockets of data that is relevant to different geographical areas, right? So Google will structure their data so that queries on the East Coast, right, might be querying data that is relevant to the East Coast, or data, or if you're doing queries, same types of query, but in the West Coast or in Eastern Europe or whatever, right? The data is structured in such a way to optimize the resources for that particular geographical area. Also, the data is also structured that is heavily redundant, so that if there are any failures or loss of information, it is somewhat structured in such a way that is redundant in several other nodes, that we can reconstruct perhaps the original data from several places, so that it's very fault tolerant, right? If there's any accidents, so we can always recreate data from elsewhere. There's many other technologies that have arisen to provide this kind of highly availability, geographically dispersed, right? It's not geographically co-located. It's huge amounts of data. Has very little or no schema whatsoever, right? And also has to be very, very fast at query time, right? Relational databases kind of fall short on these respects, and MongoDB has one of several databases that have found a home. Also the storage or the technology used to store the data has also shifted, right, from a proprietary storage that is particular to vendors of how they encode or how they actually store physically on the file system, to things that are more friendly to the types of applications that are being built. For instance, because of the explosion of web applications, and typically these web applications are written in JavaScript running on some browser, it's very common that databases will store data in the format that is friendly to whoever is consuming this data. Right? So you see a lot of databases storing natively in JSON or some binary version of JSON that is already readily consumable to these types of applications. Right? So a lot of new ideas on how to manage data for these new types of applications, these new types of challenges. Okay. So let's spend some time talking about MongoDB. So if you head over to MongoDB, you can read all about it, and I encourage you to spend some time in reading up their documentation. We're only going to skim the surface here, right? Just a very introductory discussion on MongoDB. So certainly I encourage you to read through their documentation. You can download a free version of their database server. If there's the community version, certainly they'll try to sell you that you can host your data with them, or download their Atlas enterprise solution. But for what we're going to be doing, the types of things we're going to be learning about, the community server is plenty. Okay? Also, in Heroku or AWS, they also support MongoDB instances, and they're free if you stay within a limit, which should be plenty for our purposes. So you should download it, install it, and play around with it locally. So that's exactly what we're going to be doing here today. So I've already done that. I already downloaded and installed it. I have it on my machine. Just a couple of notes on configuration. You'll need to create a directory where MongoDB can store its files, its schemas, its databases, its indices, and typically it'll be, by default, it looks for a directory under the root /data/db. So that's the first thing you'll need to do, right, to create those two directories under that path. You can configure it to be somewhere else if you want it to live elsewhere, but that's the default place where the database looks. If you start the database without these folders, it'll complain. It'll say, I can't find my data/db directory. Please create it. You might need to use sudo if you're using a Mac to create those directories. And then just to start the server, the MongoDB, typically it'll be a jar file or a zip file. that you'll need to expand. Typically, you want to put it in either in program files, program folders on Windows, or in a Mac under /user/local. That's a good place to put the particular version of your MongoDB. And there's a bin directory in there. Right? There's a bin directory in Mongo. That bin directory, you need to add it to your path, right, so that you can execute all the executables in there. Right? So make sure that you put the bin directory in your path. There's going to be 2 executables in there of particular interest. There's a whole bunch of them, right? But 2 of them are the ones that we're going to be focusing mostly on. One of them is the actual server. Right? Starting up the server, it'll start up. It'll start listening at a particular port, and then you can connect to it using the Mongo client. Those are the 2 executables that we're interested in. One is called mongodb. It's the daemon that runs the server application, and then there's just Mongo. Right? Mongo is the client application that allows you to connect to a database, just like MySQLD, right? And MySQL. MySQLD is the daemon that starts the server, and then MySQL is the client that allows you to connect to a database. Same thing here, MongoD and Mongo. Everybody okay? All right. All right. So if we head over to our terminal. I believe I had already started it, but I'll start it again. So here's a sudo mongodb. It'll start, and it'll start listening at a particular port. The default port that the database listens at is 27017. And again, it's expecting this folder to be there already, right? If not, it'll complain. It says, I don't know where to put my databases. And again, by default, this is where it listens to. Then to connect to it, you can just run the Mongo client. It'll connect to the running database. If it's not running at 27017, you'll need to explicitly say and put the URL and the port number where it's listening at, right, with the host flag, and it'll connect to remotely to whatever database you want to connect to. Right now, it's assuming that it's in the local machine, so it's assuming 127.0.0.1, right, and the port 27017. So yeah, so we're in the terminal where we can start interacting with the database. Yeah, so the Mongo client. So let's play around with the Mongo client just to get a flavor for interacting with the database. Couple things, a couple of very, very simple commands is being able to look at the existing list of databases. You can say show DBs, and right now I have these databases from various other courses that I teach. And then you can create your own database. Let's play around with the same schema that we've been looking at for the whole semester, where we have users, faculty, students, courses, sections, and enrollments. So let's create a database. We'll call it Whiteboard instead of Blackboard. And to create the database is the particular database. It's very easy. You just say use the name of the database. I don't believe I have Whiteboard, do I? I don't. And just to make sure, I'll say CS 5200, and this will be fall 2018. All right, it says that I've switched to that database, and then we want to interact with this database. Now, to interact with the database, typically in a relational database, you would interact with tables. Right? You insert into a table, you query a table, you update a table, or records in a table. Right? In MongoDB, the jargon is slightly different. Instead of us interacting with tables, we interact with what we call collections. Right? It tries to have the connotation of some long list of things, of collections, a very generic list of collection of things, okay? And instead of talking about rows or records, right, we say that these are documents, documents inside of collections as opposed to records inside of a table or rows inside of a table. Make sense? It's a different jargon, but it's the same idea. So all the commands have the following syntax. Right, they all start with db dot, then the name of the collection that you want to interact with, and then the command, the operation that you want to execute on that particular collection. Right? And you can either insert, you can find things, you can delete, you can update. The CRUD operations you would expect in any database. I also noticed that the syntax looks very object oriented, right? Where you have objects dot object function, right? And that's deliberate in that it tries to have the same connotation of JavaScript, right? The same type of interaction that you would do if you were trying to communicate this with JavaScript. Okay? So they all start with db dot collection command and then the data that you want to or arguments that you want to provide. So let's start. Let's start to perhaps insert a couple of things in here. We can say first of all we can see if there are any collections already in here. We can say show collections. There are no collections right now, right? Just like there wouldn't be any tables in a brand new database, there are no collections in a brand new database here. So to create a new collection or a new table, you just have to start inserting into it. There's no such thing as creating a table, right? Because the only thing that you really create a table for is to provide a schema, right? You say that these are the fields. The fields are of a particular data type, and they are of a particular size, yes? And you can then establish perhaps relationships as foreign key, primary key between the tables, yes? Well, there are no such thing in MongoDB. There are no schemas, right? And those that coming from relational databases might start cringing at that and says, what do you mean there's no schema? Because schemas have a very important job in relational databases. They enforce rules, right? They enforce foreign key, primary key relationships. They validate for us, right? Make sure that when you're inserting something or updating, making sure that things are actual strings, actual numbers, and actual dates, that you're not inserting garbage in here, right? So MongoDB and a lot of the non-relational databases, the NoSQL, have done away with that. It says, we're not going to, obviously it's important to validate that the data that you're inserting in here, but they're going to shift that responsibility. They're not going to leave it with the database. Instead, they're going to leave it with the application. Right? The application already does a lot of the validation. Right? Much before it gets to the database, it has to presumably has had to be instantiated in some data model, in some object-oriented data model that has presumably have done already the validation on whether these are actual dates, integers, characters, strings, whatnot. Yes? So by the time it gets to the database, presumably you already know what you're going to be inserting here. Right? So no schemas. You're free to be as denormalized as you want. You are free to be as inconsistent as you want. Not that you would do that, but certainly MongoDB is not going to judge you. Right? So let's insert a couple of things here. We're going to say db.user. So we're going to be working with a collection user, which doesn't exist just yet. To create it, we just need to start inserting into the collection. So we're going to say db.user.insert. So the insert operation takes as argument a JSON object. Right? That's basically what we're going to be storing in here. And the JSON object has curly brackets and then some username, name value pairs, right? Name value pairs. So username Alice. Let's see. Oh, I had Ada. Alice. Password. And first name, oops, first name Alice, and then last name Wonderland. Okay, notice that it says that one document was inserted, right? That was successful. If we ask to see if there are any collections, this time around it'll say yes, we have a user collection in there, and we can retrieve the content by using a find operator. So we'd say db.user.find. If find takes no arguments over here, it's as if you were doing select star from user and there was no where clause, meaning I want all the records, right? Don't filter, I want all of them. So that returns all the records that have been inserted so far, that are already in there so far. You'll notice that indeed we have the username, the password, first name, and last name in there, just like we inserted. Notice also that we have an additional field that we didn't create. Right? Notice it has this underscore ID is a field that Mongo created for us. Right? It's a unique identifier. It has the same idea as a primary key, right? The same effect. Right? These are unique identifiers that uniquely identify this. I was going to say record, this document. Right? It's unique within this collection. All right. Okay, let's insert a couple more. Now notice that there's I could have mistyped this, and perhaps I might have missed an N in here, and this would have been perhaps Bob, and maybe Bob doesn't have a password, and I might have mistyped the first name instead of first name. I could have said first, and this might have been Bob. And I might have forgotten name. And in a normal database, the database would balk at this and says, no, right? You're committing horrendous here, right? You have some records having some fields spelled one way. You have other records spelled differently. What is this? This is madness. So in a relational database, this is sacrilege, right? So we wouldn't be allowed to do something like this. But in a non-relational database such as Mongo, it's perfectly fine. Right? So there's no validation. There's no such idea of schema. Obviously, we wouldn't actually do this. Right? We would try to stop ourselves from doing this, and we will. Right? So what we'll do is that we'll rely on other ways of validation, other ways of making sure that there is some schema, some structure that will make sure that the data that is being inserted into a database is actually good. Right, but it's not going to be the database's main concern. Right? The concern of database will be other concerns, right? Making sure that the storage and retrieval is fast, that is fault tolerant, that it can be distributed in a large, wide area network, geographically. Those are the concerns, right? That we can store, that you can certainly add new fields if you want, right? If you intend to do that, and that is your actual intent. You can modify. We say that the schema is elastic, an elastic schema, meaning the schema can change over time, right? And the database is fine with it, as long as you know what you're doing, right? And that it was intentional as opposed to as an accident. Okay. All right. So this is a little bit hard to read. Imagine we had thousands of records. We can add to operations. We can add modifiers, right? That can do things such as sorting. They can make them pretty, so that we can actually read this a little better, right? Add some white spaces. But yeah, there we go. So the first insert and the first find. Also, the documents, we should think about MongoDB not, well, obviously not as a relational database. Right? Yes?
I'm kind of confused at why the user table having the key that's last name, first name does not qualify as a schema.
What do you mean?
Like if we go to the share and the 35 command that we get.
Yep.
So why doesn't username, password, first name, last name can be thought of as columns of a schema?
Mm-hmm.
Because
Well, so each object has its own schema, right? But the collection doesn't have a schema. So in a table, there's one schema, and all the records have to have the same exact schema. All the records have to have the same columns with those names, right? And they have to be of that particular data type. So you're not free to all of a sudden create a new column, right, on the fly in a relational database, right? The schema is set. If you want to change it, perhaps you would need to alter the schema, right? And all validation, any updates, any inserts will always be validated against that schema. If I was expecting an integer and you pass me a string, the database will give you an error. Or it'll say, oh, no. Or if you try to insert with a column that doesn't exist, it'll say, no such column in that schema. So there's a lot of validation that goes on with the relational database where when you're doing updates, right? Say you do a query and on a field that doesn't exist, it'll say, well, no such field on that table. Here, there's no such validation. If you're querying on something that doesn't exist, it'll just be ignored, right? Or if you're inserting a record with fields that are completely different from any other record, that's totally fine. Nobody's going to validate, and because there is no centralized schema for that collection. That make sense?
So if I have some mechanism through which I can validate,
Yeah.
will that convert my NoSQL to a relational, or that doesn't work that way?
Well, no. We will do validation, not at the database. It's not the data. What I meant is that the database won't have that responsibility. The responsibility of validating all the schema, right, is going to be shifted up to the application level, right, through several tools, through several libraries, through drivers, right, that are going to have the responsibility of validating all these things before making it to the database. But the database itself will not have those responsibilities. Okay. So even though it lets you do this, it's not something that you would want to do it, right? Unless you intend to do it, which is perfectly fine, right? It's in medical systems, it's very often that a product goes out, right? And the doctor needs to store certain information, but there are certain attributes that come up in when they're consulting with their patients, right? And they're not measuring a particular variable, right? It says, I don't have anywhere to put this. So one of the features might be that, well, I want to add additional fields that I want to keep track of. So we would like for them to be able to have an elastic way that they could add fields and start capturing this information. And the database would support this, right? Yeah. So this is something you would never actually do, right? At least not by mistake. I'm sorry, if you would, it's either by mistake or hopefully it would be by design as opposed to by mistake. Okay. Right. Notice that what we're storing are objects. Right? These are JSON objects that we're storing. So oftentimes you should not think of these as records at all. Right? That what we're storing are objects. So you should think about some of these relational databases as object databases. Right? So these are instances of objects that have been stored in the database, and it provides mechanisms for you to be able to manipulate them, retrieve them, update them, interact with these objects that have been stored in the database. Right? You should think of these more like, for instance, Java has a feature where you can you have an instance object in memory, and you can has an API that will allow you to write that object down to a file. Yes. And then there are libraries that would allow you the same library can be used to take that file as an input and reinstantiate that object in memory. It's the same object that was written to a file now gets reconstituted in memory. Yes? So imagine there were an API that would allow you to handle thousands of these objects, right? That could be stored in a file and then readily reinstantiated into memory. So in that sense, MongoDB is closer to that. Right? It's a database that allows you to store, update, retrieve, manipulate objects that are being stored in a file system. Right? To that end, these objects, can be fairly complex. Right? They can make full use of objects. Right? So they don't have to be flat like relational databases where you just have fields, right? And fields have their particular values, and they're flat, right? They can't so fields cannot contain other fields, right? So you can't nest data inside of a field. A field has a primitive data type, and that's it. Right? It cannot have a compound. Right? The only way to create structures and hierarchies in relational databases is to have foreign keys, right? And split the data amongst multiple tables that have to be joined. Yes? In a non-relational database such as MongoDB, the schema, right, the structure of the data doesn't necessarily have to be flat, name, value, name, value, name, value, name, value. Instead, the values themselves can be other objects, okay? Or it could be arrays of objects of arrays, arrays of objects. Or it could be indefinitely complex, right, of what you can actually store as a document. And typically in a relational database, typically we want to split it into multiple tables to make sure that is normalized, right? Make sure that we don't have redundancy, that information is stored in the particular table and whatnot. Here, we also have those kinds of concerns, right, of redundancy, of inconsistency. We have the same types of concerns here as well. But we have other options. The problem becomes a little bit harder when you start thinking that these objects might have fairly complex structures that you're storing. Right? These objects might be objects that contain other objects, that contain other objects, that contain other arrays of objects. So they'll be fairly complex. Now, having said that, one of the distinguishing factors between relational databases and non-relational databases is that the less emphasis on relationships. And there's a huge de-emphasization of relationships, meaning the data typically is not spread over multiple collections or tables. It'll be much more typical that all the information will be stored as one single document. Right? So instead, in a relational database, if you need to create a structure, you need to join multiple tables to reconstruct an object. Right? Imagine in the assignment where in the JDBC assignment or the JPA assignment, you had courses that contained lessons that contained what did they contain? Courses contain lessons. No, modules contain lessons that contain topics, right? So it was fairly hierarchical, yes. And to accomplish that, you need to join all these tables and reconstruct the objects. So map it from something that was flat to something that was very hierarchical. Yes? It would have been nice if we could have stored the object itself in its original structure in the database, and we could have recreated that object back from the database and just reinstantiated it back into the object. Yes? It would have been really cool without having to go for this information in this table and then that information from another table and then iterate over that other table over there and reinstantiate and reconstruct the structure in the object. Yes? Right? So object databases like MongoDB allow you to do just that. Right? The original object can be stored verbatim, the way that it came with all the structure that it had of arrays of objects of arrays of all embedded information. And that's actually the preferred way of storing things in Mongo. Mongo is uniquely designed to optimize storing whole objects, complex objects, as opposed to storing multiple pieces of information across multiple collections that then you would need to reconstruct and go fetch all this information in multiple collections. Right? So Mongo does not, it does support it. Right? It does support you being able to fetch things from multiple places, but it's not its forte. right? If you find if you find your way in a non-relational database where you're storing multiple things in multiple collections and then reconstructing the structure, probably you might want to stick to a relational database as opposed to a non-relational database. Okay? All right. So one of the distinguishing factors I was saying in non-relational and relational databases is that there are no relationships, or they're very minor, and there are no joins in MongoDB. There's no such operator of joining, right, data that lives in one collection with data that lives in another collection, right? And so because the whole point was that you wouldn't have split it up in the first place. You would have stored it as a single object. Okay, makes sense? Although it has a minor support, and we'll see the limitations of it on how these could be structured. Okay. So yeah, so here's an example of name value pairs, different data types. Here you have name is a string, age is a number, group is an array of strings, but it could have been an array of other objects. Okay, and then here's a collection of multiple instances. All right, so now we have a collection, and we can query, and we just did the first find. Okay, we did pretty. All right. Okay, so let's look at something more interesting.